Cosine. So you know that f prime is going to be cosine of x cubed, but then you have to multiply by the derivative of the inside. What is the derivative of the inside? Yeah, so you have 3x squared. So if you clean it up, it's really 3x squared cosine of x cubed. So using what you found in part A, can you tell me what the integral of this is? What is the integral of that? Sine of cubed plus c. Yeah. So the real question though is, let's say I didn't give you that to begin with and I just said solve that without A. It's a little bit trickier. I led you to the answer by showing you one direction and therefore you knew the other direction. What we're going to learn today is a method called W-Substitution, which helps us do this kind of integration, which is effectively undoing the chain rule. We're undoing the chain rule. It helps us notarize what we're doing, so it's relatively straightforward, although this is a method where you're going to run into dead ends, and that's fine. You're going to have to pick something and test it, and maybe it works, maybe it doesn't. Yes, Gil? So if it doesn't work, then I'm going to show you the method. So you're going to go back to the beginning and try something else. The same method, just with a different starting point. So, for example, let's do a couple of these. Part A and part B there. See if you can figure that out by yourself. I didn't give you the forward direction, but I bet you can figure out what the integral for each of those is based on what we just did. Try to do A. Let's just do A first. Do A. Tell me what the integral of 2x cosine of x minus what? Yeah, minus, oh, not highlighter. Minus sine of what? Exactly, plus c. How would you test this? How do you test to see if it's the correct integral? You take the test by taking the derivative. So if you did d dx of negative sine of x squared plus c, what's the derivative of sine? That's what we're figuring out right now. If you did the derivative of sine is cosine, right? So do you need that negative? No, you actually don't need that negative. So it's just going to be cosine of x squared times the derivative of x squared. What's the derivative of x squared? 2x. And you can put that up front. So is it correct? Yeah. It does check. Yay, it does check. Okay, let's up the difficulty just a little bit. Try part B here. Try part B. It's very hard to factor in now. The 4 kind of messes things up a little bit. So what do you put in front? What is this going to be? 2 what? Cosine of? You're so close. It's got to be, this one has to be negative because the derivative of cosine is negative sign and you want it to be negative, you want it to be positive, so negative and negative is a positive. So you would check this the same way. You do the derivative. What can you do with that negative 2 if you're doing the derivative? What could you do with this? You could just take it out and put it out in the front, right? What's the derivative of cosine? Oh, it's going to be negative sine of x squared times the derivative of x squared. That's the chain rule, right? So what do you have here? Oh, the negatives cancel, so you're left with 2 sine of x squared times 2x. And is that what we want it to be? It is. It absolutely is. So you check these just by taking the derivative. It works. Nice. So these are ones we can do in our head. You were able to correct for the absence of 4 by just plopping that 2 in there. Keeping track of everything gets more complicated, though. It gets more complicated, though. So, for example, it might be helpful to make a substitution. But before we make the substitution, just ignore that for now. You need to remember your basic integrals. You need to remember them. You need to remember them. And you guys, you will get your tests back once everybody's taken them. There's a lot of people that need to take them. The AP's kind of messed up the test schedule. Do you remember what the integral of just e is? Like, what's the integral of e to the x? Do you remember that? What is the integral of e to the x? E to the x, because the derivative of e to the x is e to the x, right? So in this case, it's almost the same thing. The integral of e to the 4t. Anybody want to get to random guess what the integral of this is going to be? Random guess. Just guess. What do you think it's going to be? E to the 4t over 4. And guess what? You just got it correct. You just got it correct. If you just said the integral of this, let's test it and see if it works. If you just did this, you would test it by doing this, right? But if you take that derivative, that's the same thing as e to the 4t times the derivative of 4t. What's the derivative of 4t? 4. So you have this random 4. You don't want that, right? So what do you do to the original? What do you put there? A 4 in the denominator. So instead, the antiderivative is going to be e to the 4t all over 4 plus c instead. Because when you take the derivative, the 4 is in the denominator, nukes that 4 out. Here's the thing, we can keep track of that, but we need a system for that. Because if I make it, a little bit more difficult, you're not going to be able to keep track of all the things that are going on. So what we can actually do instead is this. Take a look at this substitution here. Let w equal 4t. If we let w equal 4t, what does this become? The integral of what? What does it become? E to the w. Okay, and you can't write dt because is w the same letter as t? No, you do not want that to happen. So what you do is you need to take this and go, okay, what is dw dt? If I take the derivative, what is it? 4, exactly. So what does dw equal? 4 dt. So what does dt equal? dw over what? dw over 4. So where can we plug this in? Oh, right there. What does dt equal? So what do we put right here? dw over what? 4. What can we factor out to the front? You can factor out a constant, right? You can factor out a 1/4. So what does this become? It becomes 1/4 the integral of e to the w dw. Well, what's the integral of dw? Of e to the w? E to the w plus c. Oh, but what is w? 4t. So what's our final answer? 1/4 e to the... Is that the same answer we got before? But that's a system. This is where it forces that 4 to exist. So here's the thing. Did it tell you the substitution here? Yes. Is it always going to tell you the substitution? No. And is substitution always going to work? No. But you're going to look for certain signs that help tell you that substitution will work. Let's do one more here, and I want you to first just guess. Don't try it yet. Your first step is going to be guess. If I could actually spell guess, that would be helpful. Guess the sub. So in this case, what do we want w to equal? Anybody have a guess what we should make w equal here on this case? Anybody want to guess? Yes. T squared plus 1. So Caleb, what is the what is dw dt equal to? Take the derivative. What do you get? Yes. So what does dw equal? 2t dt. So what does dt equal? dw over what? 2t. So you have two things you're going to substitute here. See those two things? Where are they going? There and there. What do you end up with? 2t e to the w times dw over 2t. What's the magical thing that's about to happen right now? There's something hugely, hugely important that's about to happen. What happens right now? What can you simplify? Yes, and because you can cancel it, it means you have a path forward, because can you integrate multivariable functions? No. So now what do we have? Just the integral of e to the w what? Oh, what's the integral of that? E to w plus c. Oh, but what does w equal? It's right there at the top. T squared plus 1 plus c. Hey, look, we just did it. And what is the key? Take a look here for a second. Look at the w's that we've used. Look at the w's we've used. How do we know what w to pick? What is there? We're looking for something. What? The exponent is a good target, but it's not necessarily where it is. It's a relationship with something else in the equation. What do you see? Yeah.
It's like the function inside that you would use the...
Yes, so it's the function and the derivative. It's the function and the derivative. So what did we do for the substitution on that second one? Caleb said it was t squared plus 1. Well, what's the derivative of t squared plus 1? Is 2t already there? When you see a function and its derivative, that's a very good sign that the function that you see is the substitution you should make. It doesn't always work, but it allowed us to cancel in that case. It allowed us to cancel. So this one right here is slightly different. It's not an exponent, but do you see a function and its derivative? Yeah. What do you see? X to the 4th plus 5 and x3. Take as many constants along as you can, because what's the derivative of a constant? 0. So, what do we think the w should be, Eddie? X to the 4th plus 5. Okay, you guys try doing this all by yourself. So, maybe you got dw dt is equal to 4x cubed. See, dw is equal to 4x cubed dt. So dt is equal... Oh, dx, thank you. It is dx. Sorry, thank you for that good catch. It is definitely dx. So what does dt, or dx, sorry, dx equals dw over cubed. So now you take this and plug it there, and you take this, sorry, I'm highlighting like a crazy person today. This one goes right there. So what do we end up with? We end up with something kind of helpful. X cubed times the square root of w, and instead of dx we write dw over 4x cubed. Oh, what cancels? Hey, that's nice. And we can factor out that 1/4, right? So what do you end up with? 1/4 the integral of the square root of w dw. That is something you need to be able to knock out of the park when you integrate. What do you translate it into first? That's radical form. Put it into the what? Yeah, what's that called? Exponential form, maybe, right? And that you need to integrate just like you've integrated many, many times before. What's 1 greater than a half? 3 over 2. So what do you have there? W 3 over 2 over, and there's a 1/4 right here, plus c, and you just need to simplify that. Dividing by 3/2 is the same thing as multiplying by what? So 2/3, w to the 3/2 plus c. What can? Oh, it's going to be what? 1/6, I think. 1/6 w to the 3/2 plus c. Now, do we want to leave w in there? No. What does w equal? Got to throw it in there. X to the 4th plus 5. So what do you end up with? 1/6 x to the 4th plus 5 to the 3/2 plus c, and that would be your final answer right there. So when you did this, I imagine you have something that looks like this, right? And then you had dw over 4x cubed, like this. You did this out, and I imagine you ended up with this. You have that, right? That's a problem, right? All of this is fine. You've done all of this work is correct, but you've now hit a wall. So at this point, you would ask yourself, is there anything else I could substitute in? Or is this even doable using U-substitution? I leave this as an example of you can't do this one right now. Change one little tiny number and it changes for something that's relatively straightforward to you hit a wall, you can't do this one. So I'm not going to give you ones where you hit walls, but I wanted to show you that just because you have a hammer doesn't mean you can use it to solve everything. Does that make sense? Okay, so let's go to ones you can do though. If we did this out perfectly, we would say w is equal to e to the t. So dw dt is also equal to e to the t. So dw is equal to e to the t times dt. So that means that dt is dw over e to the t. You then substitute your dt right there, and you substitute your w right there. So what do you end up with? The integral of of what? W over 1 plus w times what? dw over e to the t. But what is e to the t? That is w. So this ends up being w over 1 plus w times dw over w. That cancels. Oh, look at that. So you end up with 1 over 1 plus w dw, which is the integral of 1 plus w to the negative 1 dw. And you guys remember that that is indeed ln 1 plus w plus c, but w is e to the t. There's a couple ways. There's a couple ways, but that's just how I would have done it. The one thing that this adds in, I want to show you, is this is true no matter where you are in the problem. Sometimes you're going to have to substitute again. Always, if you get stuck, the first thing you should look at is there anything I can substitute in at this point? Careful, because you don't want to end up back where you started. Like you try to go somewhere different to get somewhere new, not go somewhere different to end up back where you started. You have to be very careful about that. Okay.